In order to find this derivative, we're going to begin by writing out the definition of the derivative. And that is the limit as h approaches 0 of f of x plus h minus f of x, and all of that over h. What we're looking for are these two pieces to plug into our formula. So according to our equation in the beginning, f of x is going to equal the sine of x, and f of x plus h is going to equal the sine of x plus h. Now that we have our pieces, we can plug this into our formula. We'll end up with the limit as h approaches 0, and in our numerator, our f of x plus h is going to be replaced by the sine of x plus h, and our f of x is going to be replaced by the sine of x. And we're going to subtract. Everything's over h. Now we can distribute through that negative, take care of our subtraction, and we'll end up with the sine of x plus h minus the sine of x over h. From here we have to use an angle addition formula from trigonometry. We're going to convert the sine of x plus h into the sine of x times the cosine of h plus the cosine of x times the sine of h. And then we'll still be subtracting the sine of x, and everything will still be over h. From here we want to group together the terms in the numerator that have the sine of x in them. So we'll have the sine of x times the cosine of h minus the sine of x plus the cosine of x times the sine of h, all over h. From here, we can factor out a sine of x from those two terms we grouped together in the numerator. So we'll have the sine of x factored out, and that'll be multiplied by the quantity cosine of h minus 1, and then that's all plus the cosine of x times the sine of h over h. Now we're going to break up our single fraction into two separate fractions so we can use some limit identities to simplify. We're going to have the sine of x times the cosine of h minus 1 over h plus the cosine of x times the sine of h over h. And from here, we're going to factor out in front the sine of x and the cosine of x portions of our terms. So we're going to have the sine of x times the fraction cosine of h minus 1 over h. And that's going to be added to the cosine of x times the fraction the sine of h over h. And we've done this because, as you can see up top, we have some identities for those functions when we're taking limits that approach 0. So if we apply that limit as it approaches 0, we get the sine of x times something approaching 0 plus the cosine of x times something approaching 1. And that gives us our final answer, that our derivative of sine of x is cosine of x.